In this video, we're actually going to look at converting some metric units. In the previous video, we looked at the different prefixes that you're likely to see in a science class. But let's actually do some conversions here. So let's say, for example, that I buy a computer, and let's say this computer has, we'll say, 500 gigabytes for the size of its hard drive. And let's say I wanted to convert that to we'll say decibytes. And you'll see in just a minute why today we don't use deci for bytes. As far as hard drive sizes goes, we use gigabytes because they have gotten so good that they can contain massive amounts of information. But anyhow, so the first thing that I'm going to do is I'm going to write down my letters for the prefixes for the or the beginning letters for the prefixes. So we said the great man, so TGM, the great man, King Hector, died by drinking chocolate milk under new Parliament. Remember we said this was a mu, it's a Greek letter, but it kind of looks like a U, so we're going to call it under. Okay, so I'm going to put a dotted line in between my M and my K and in between my M and my mu. And the reason why I put a dotted line here is because remember, anytime we're in between the dotted line here, we're moving the decimal one place because we're multiplying by a factor of 10. Anytime we are outside of the dotted lines, we're going to move our decimal 3 places because we're actually multiplying or dividing by a factor. Well, I guess in this case we wouldn't be multiplying, we would actually be dividing by a factor of 1,000, and here we would be multiplying by a factor of 1,000. And anytime you cross this line, you move 3 decimal places also. So you'll see what I mean in just a second. Alright, so 500 gigabytes, I'm going to put a dot at my G. So 500 gigabytes, and I want to go to decibytes. So on here, the little d refers to my deci. So in order to get from my G here on the left to my D on the right, I've got to move to the right. So I'm going to count. 3, or G to the M is 3 spaces because I'm on the outside of this dotted line. And from M to K, that's an additional 3 spaces because I'm crossing this line. So from G to M is 3, from M to K is 3, so I've got a total of 6 spaces I'm moving. So now I'm going to count by 1 because I'm inside. So once again, that's 3, 6, 7, 8, 9, 10. So this means I'm going to move 10 places to the right. So I'm going to take my number here, which is 500, and even though the decimal is not explicitly placed in this number, we know that it's understood to be at the end. So this means that I'm going to take the decimal and move it to the right 10 spaces. So let's do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And zeros go in the little U shapes as the placeholders. So now we put some commas in, so I would put, let's change different colors here. So I would put a comma here, I would put a comma here, I'd put a comma here, and then another comma here. So let's see, that would be, so that's million, billion, trillion. So it would be 5 trillion. So it's a lot easier to say 500 gigabytes as opposed to 5 trillion decibytes. So that's why they use the nomenclature giga. And if I wanted to put this in scientific notation, I would say 5 times 10. Well, this number, the decimal, the leading number here you want to be between 1 and 10. So that's our 5. So let me back up just for a second here. So let's choose a different color. And if I looked at this number, so this number is 5 trillion, where could I put the decimal in this number to make it between 1 and 10? Well, the decimal would go right there. Because if I put it over here, it would be 50, that's bigger than 10. Or if I put it to the left, it would be 1/2, and that's less than 1, so that's not good either. So if I put the decimal here, it makes this number between 1 and 10. So now, because I put this decimal in between these two numbers, how would I have to move this decimal in order to get my original number back? Well, I would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I moved 12 spots to the right. So this would be 12. So that's what the exponent means, is how many times you move the decimal. Sometimes people will mistake this as meaning the number of zeros we have, but that's not the case. This 12 means the number of decimal places that you move. So 5 times 10 to the 12th is equivalent to this number. And when you have really big numbers like this, it's probably best to use scientific notation. So the answer is going to be 5 times 10 to the 12th decibytes. Alright, so let's pick another example. We went from gigabytes to decibytes, so the number got really big. So now let's go the other way. Let's say if I've got a number that says I've got 23.4 microliters, and I want to convert that to, let's say, teraliters. So big T, big L, teraliters. Okay, so once again, I'm going to write down the beginning letters for my prefixes. So I'm going to say, the great man, King Hector, died by drinking chocolate milk under new parliament, and I'll pick a different color and put my dots in. Now remember, we said the dots separate counting between ones. I count between ones when I'm in here, and I count 3 decimal places when I'm on the outside. Okay, so going back to here, I'm starting at micro, so I'm going to put a little dot underneath my micro, and I want to go to tera, so I'm going to count. So to go from my micro to my tera, I'm going to go from this dot over to the left. So let's count. So that's going to be 3, 4, 5, 6, 7, 8, 9, add 3, which is 12, add 3 more, which is 15, add 3 more, which is 18. So I'm moving the decimal place 18 places to the left. Now that's supposed to be an arrow, but it's 18 spaces to the left. Now one thing I want to caution you, when you're moving these, sometimes I've seen students, they'll actually put their mark in between the letters. Don't do that, because you're often to get off by one. You'll either add an additional one or take one away. So make sure when you're moving your decimal, you're actually going on the letter and not in between the letter. But anyhow, we know we're moving 18 spots to the left. Okay, so in this number 23.4, so if I've got 23.4 and I'm going to move this decimal 18 places to the left, well, I know that if I move it 1, 2, I've got to move it 2 spaces to put the decimal immediately to the left of the 2. So that means that I'm going to add 16 zeros in front of this. Okay, so let's see if I can fit these in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2, 3, 4 teraliters is the answer. So this is an extremely small number because this is an extremely large prefix. Okay, so this is the answer, but once again, this is kind of messy. You wouldn't really do this. You would use scientific notation. So once again, in order to put, where can I put the decimal in this number to make it between 1 and 10? Well, if I put it in between the 2 and the 3, that satisfies my number being between 1 and 10. And in order to move this yellow dot out to meet this orange dot to equal what the number really is, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I'm moving it 17 spots to the left, so it's 2.34 times 10 to the negative 17th power, and that is teraliters. So kind of a rule of thumb, if you've got a really small number, which this is a really small number because we've got a bunch of zeros in front, you're going to have a negative exponent. So here is our negative exponent. So negative just means I'm moving the decimal to the left, in which I had to move this yellow one to the left to get to where the orange one is. If I've got a really big number, so let's do that up here. So if I've got a big number, say 5 times 10 to the 5th, this is a positive exponent, so that means the decimal is moving to the right. So 5 times 10 to the 5th would be 5 with 1, 2, 3, 4, 5 zeros, so that would be 500,000. So just keep in mind that this 5 doesn't necessarily mean number of zeros, it means how many decimal places. It just so happens in this example the number of decimal places equals the number of zeros that I have to put in. But just make sure that you're careful with that.